Hey everyone, here's another video with Mrs. Suderman. We're going to be looking at some additional problems from Chapter 5, Section 2 of your textbook, which you can read to see some examples. But we're going to be looking at quadratics in both standard and vertex form. So let's get started. Number 1, we have g of x equals negative x squared minus 2x plus 3. So we need to figure out, first of all, does it open up or down? So before I get started, I'm going to list out a equals, b equals, and c equals. Remember, this is ax squared plus bx plus c. So that means a is negative 1, b is negative 2, and c is 3. So does this open up or down? Well, we have to look at the value of a, and since a is negative, it opens down. The axis of symmetry, remember, that's x equals negative b over 2a. So if we have negative b, which is negative 2, divided by 2 times a, which is negative 1, we'll have 2 over negative 2. So our axis of symmetry is x equals, don't forget the x equals 2 divided by negative 2, which is negative 1. Now that we know where the axis of symmetry is, that line will go through our vertex, since our parabolas are symmetrical. So the x value of the vertex will match the axis of symmetry. And then to get the y value, we need to plug it in. So we'll have negative of negative 1 squared minus 2 times negative 1 plus 3. So negative 1 squared is positive 1, but then we make it negative again. So we have negative 1, negative 2 times a negative 1 is a positive 2, and then plus 3, and that equals 4. So our vertex is at negative 1, 4. And because we know the y value of our vertex, we also know the max or min value is 4. And then because it opens down, that means this graph has a maximum. It doesn't have a minimum because it goes towards negative infinity, and we can never reach it, so it only has a maximum value. Let's graph what we have so far. So the vertex is at negative 1, 1, 2, 3, 4. And remember the 1, 3, 5, we're just going to multiply by a, which here is negative 1. So we'll have negative 1, negative 3, and negative 5. So that means starting at the vertex, we'll go out 1, always just out 1 to get to the next x value, and these tell us to go down 1. From those 2 points, not starting back over at the vertex, from those 2 points we're going to go out 1, down 3. From those 2 points, we'll go out 1 again, and this time we'll go down 1, 2, 3, 4, 5. And then you would go 7, 9, and so on. Draw in the parabola. Hopefully better than me. Okay, so for the x-intercepts, they crossed at nice pretty places. So we have x-intercepts of negative 3, 0 and 1, 0. Remember, if they do not cross at pretty places, the y value is 0, so we would set our equation equal to 0 and solve for x, using one of the ways we've already learned. For the y-intercept, remember the x value is 0, so you could plug 0 into the equation, or just know that it matches the value for c, which here is 3. The domain is all real numbers, and the range is y is less than or equal to our maximum value, which is 4. How does this graph compare to our parent function? Well, it's the same shape, but it's the opposite direction, and it's also moved left and up to a vertex of negative 1, 4. Okay, so now let's practice switching some equations from vertex to standard form. So number 2, we're given 2 times x plus 3 squared minus 2. So it's pretty easy to go from vertex to standard form. All you have to do is multiply it out. So we have 2 times, remember x plus 3 squared is x plus 3 times x plus 3. So when you multiply that out, you get x squared plus 6x plus 9, and then our minus 2 is still there at the end, You'll distribute the 2, so you get 2x squared plus 12x plus 18, and then minus 2. And then collect your like terms, so we get f of x is, in standard form, 2x squared plus 12x plus 16. Use a different color, switch it up a little bit. Let's use purple. Okay, so we have f of x equals negative 1/2 x minus 2 squared plus 1. So again, that's x minus 2 times x minus 2. So we have negative 1/2 times x squared minus 4x plus 4, and then plus 1. Distribute that negative 1/2. Negative 1/2 times the negative 4 is a positive 2. Then we have 4 times negative 1/2 is a negative 2. So f of x multiplied out is negative 1/2 x squared plus 2x minus 1. I would like for you on your own paper to do number 4. Okay, and finally, 2 quadratic applications. The path of a soccer ball is modeled by this function where h is the height above the ground in meters and x is the horizontal distance that the ball travels in meters. What is the maximum height the ball reaches and at what time? That should say at what horizontal distance, since that's what x stands for. Sorry, little typo. Horizontal distance as the ball reaches its maximum height. So these keywords are maximum. So that tells us that we are going to be looking at the vertex, since the vertex is where the maximum value occurs. So we're looking for the maximum heights, we're looking for the maximum y value, and at what horizontal distance is that maximum height, so that related x value. So to find the x value of the vertex, we use negative b over 2a. So here we'll have negative b, which is negative 0.25 over 2 times a, which is negative 0.005. And when you divide that, you get 25. So there's our x value for the vertex. To figure out the y value, we just need to plug that in. So we'll do negative 0.005 times 25 squared plus 0.25 times 25, and that will give us a value of 3.125. So we know that the vertex is at 3.125, therefore the max height is 25 meters, and that will be when the horizontal distance is the max height, whoops, is the y value. The max height is the y value, so you have 3.125. That's when the horizontal distance, the x value, is 25. Sorry for the mistake. Okay, and then finally number 6. A baseball is thrown with a vertical velocity of 50 feet per second and an initial height of 6 feet. Here's the equation for the height, where t is time is in seconds. How many seconds does it take to reach the max height? So again, we're looking for that y value. And at how many seconds, that's the x value, or the time. So we do the same thing we did before. So we're going to plug in negative b over 2a. So we'll have negative b is 50 divided by 2 times a, which is negative 16. So that will give us positive 1.56 seconds, and that's at the time it will reach its maximum height. And then to get the y value, we just plug that in into our formula. And that will give us a value of 45.06. So the maximum height for the baseball is 45.06 feet, and that will happen at 1.56 seconds. Okay, that's it. Hope you took notes. If you have any questions, let me know, and I will see you later. Bye, everyone.